Hi there, and welcome to this lesson on Pure Mathematics 2. In this lesson, we're on Chapter 4, 4.2, and we'll be considering factorial notation and NCR notation, how they connect to Pascal's triangle that we met in the last lesson, and very much leading and preparing the way for the next lesson on the binomial expansion. First of all, factorial notation, 5 factorial, written as 5 with an exclamation mark after it, means multiply all the numbers from 5 downwards till you get to 1. 5 times 4 times 3 times 2 times 1, which gives you 120. NCR notation, 2 ways you'll see it written down. Sometimes it's written as NCR. It means N choose R, or that's one way of understanding it. I think in the last lesson we considered a class with 6 students in, and we had to choose 3 of those students. Then 6 choose 3 would be the total number of different ways of choosing 3 students out of a class of 6. It's sometimes written with vertical brackets with the N over the R. And here is how you would calculate it by hand. NCR is equal to N factorial divided by R factorial times by N minus R factorial. So the example we were talking about, 6 choose 3, if you were choosing 3 students out of 6, then that would equal 6 factorial divided by 3 factorial times by 6 minus 3 factorial. And if you throw all of that into your calculator, you'd get 20. And you could do it either just putting these numbers in, or if you have the button on your calculator, you just have to press 6C3 on your calculator, and that will give you 20. Okay, let's have a look at an example as to how this can be useful. In the last lesson, we said if the numbers are small, it's always a good idea just to very quickly draw Pascal's triangle. It doesn't take very long at all, and all of the answers are there for you on Pascal's triangle. Now that only becomes problematic if n becomes very big, if the number of rows that you're going to have to go through for Pascal's triangle becomes large. In that case, it's probably best not to draw Pascal's triangle, but to use the NCR button on your calculator or the formula. So this example is saying if you had to go all the way down to the 20th row of Pascal's triangle, what would the first 3 terms be? Now the first term will be 20 choose 0, 20C0. Second term will be 20C1, and the third term will be 20C2. Okay, I'll let you have a go at making sense of this yourself. So see if you can work out what the first 3 terms in the 20th row of Pascal's triangle would be by using the formula for NCR, and then check your answer just using the NCR button on your calculator. Have a go, pause the video, come back when you're ready. Okay, so what were we talking about here? We're talking about the 20th row in Pascal's triangle. That's the formula for working out any number in Pascal's triangle. It's the formula for working out NCR. So if we wanted the first term in the 20th row, then 20 would be what we'd use for the 20th row in this instance, then C, and 0. Now it's worth remembering that. So the very first term, we don't have 1. The very first term, we have 0. So the first term would be 20 choose 0. Putting those numbers in, so n is 20, r is 0, that would give us 20 factorial over 0 factorial times by 20 minus 0 factorial. One thing to notice there, 0 factorial, and this will happen if you use your calculator to work it out, it's defined to equal 1. Now, using the sort of way we had for calculating factorial, that wouldn't necessarily look like it should be the case, but 0 factorial, for various reasons, is defined to equal 1. So popping all of that into your calculator, you get 20 factorial over 20 factorial, which gives you 1 for the answer. Now, if you remember Pascal's triangle, the first term in every single row is 1. So all of the rows begin with 1, and then after that they change. The second term in Pascal's triangle, the 20th row, would be 20 choose 1, which is 20 factorial over 1 factorial times 20 minus 1 factorial. That simplifies to that. Pop that in the calculator, and you should get 20 for the answer. And the third term in the 20th row would be 20 choose 2, which is 20 factorial over 2 factorial times 20 minus 2 factorial. Again, pop all of that in your calculator. You should get 190 out. So those would be the first 3 numbers in the 20th row of Pascal's triangle, 120 and 190. Now, the application of all of this, which we're coming to, is the binomial expansion. And the binomial expansion deals with this sort of situation where you've got 2 things. That's what the bi means in binomial. So we've got one term here, which is 1. We've got a second term here, which is plus 2x. And then that bracket, we're going to calculate to the power of 30. Now, to do that by longhand, you'd have to write down 30 brackets, each of which you've got 1 plus 2x in, and then multiply all of those 30 brackets together and collect all the terms. The binomial expansion gives us a very quick method for working out specific terms we're interested in. Now, in this example, we're asked to find the coefficient of x squared if we were to multiply all of those 30 brackets out. And it's a surprisingly powerful method, this. So if we want the x squared term, if you imagine those 30 brackets, we want to take x out of 2 of those 30 brackets, or 2x out of 2 of those 30 brackets. And then we multiply those together and we get x squared. The other 28 brackets, we'd have to choose the 1. So if you were writing all these 30 brackets out, essentially what we're doing is choosing the 2x from 2 of the brackets, and then we're choosing 1 from the other 28 brackets. And the coefficient will tell us how many different ways there would be of doing that. So how many different ways of choosing 2x from 2 of the brackets and 1 from the other 28 brackets. And if it's the x squared term, then using NCR, we'll have 30, because we're multiplying out 30 brackets, C, and then 2, because it's the x squared term we're interested in. We're interested in taking the 2x from 2 of the brackets. That's the real reason for the 2. So the coefficient will just be 30, choose 2, 30C2. 30 because of the power, and 2 because we're taking x from 2 of the brackets. Now, if that made any sense, have a go at working out the coefficient yourself. It's very quick. There are no tricks or catches here. But pause the video, have a go, come back to me when you're ready. Okay, let's have a look at this. Well, as we were saying, the x squared term is made up of 3 parts. I think we'll start with this last part first. We want the x squared term. That means we're going to have to choose 2x twice. So from 2 of the 30 brackets. That'll give us 2x squared. For the other 28 brackets, we're going to have to choose 1 every single time. And then the 30 choose 2 is to tell us the number of different ways we could have done that. So out of those 30 brackets, if we had to choose the 2x twice, then that's 30 choose 2. 30 choose 2, you could do that just on your calculator. That will give you 435. 1 to the power of 28 is just 1, and 2x all squared gives us 4x squared. Multiplying those together gives us 1,740 x squared. And 1,740, that's the coefficient of x squared. So if we'd written down these brackets, all 30 of them, multiplied them all together, collected together the x squared terms, in total, there would have been 1,740 x squared. Okay, that gets us to the end of this lesson. If you've got the textbook, then turn to page 66 and have a go at exercise 4B. Thank you very much for listening, and cheerio.